Hi, this is Jeremy Jansen, and I'd like to welcome you to the March 2010 issue of Reason Wizardry. This month we're going to be looking at custom LFO waveforms. Often, when I start out to create a sound, I have an idea of what I want in my head, and in order to get there, sometimes you need a modulation on a certain parameter that isn't necessarily covered by the waveforms that you're given with the presets in Maelstrom or Thor. So if you want to create your own LFO waveform, you have to delve a little bit deeper and you have to overcome some of Reason's inherent limitations. So we're going to get right into that, and we're going to create some custom LFOs and then take that to the next level as well. Alright, so I've got a very basic patch set up here. I've got a Maelstrom, unfiltered so far, going through a unison, and I've also got a matrix here. So first I'm going to turn on a filter on the Maelstrom. Okay, so what if I want to create a filter sweep on this patch that isn't really covered by the available waveforms we've got here? The logical first port of call for something like that would be to use a matrix device, because you can draw in your waveform. So let's do that. Flip this rack around here and send our curve CV out to filter A and raise the modulation to max. And we'll turn our filter frequency down. Okay, so now I'll just draw in a waveform here. Say I wanted a bit of an upsweep followed by another upsweep like that. So that's nothing I can really get out of the existing LFO shapes. So I've drawn that in. Let's hear how it sounds. Okay, I already mentioned there's inherent limitations to creating custom LFOs, and right there is the first major one that we're going to be tackling this month. Basically, it's stepped waveforms. We can draw in what we like in the matrix, but you can hear each step. And of course, the slower the modulation, the more obvious it is. You can try speeding things up. And that does help to some degree smoothen things out, but then you're going to have a very fast waveform. And what if you want a slower modulation? You could work around that using some of the other techniques that we've talked about, chaining together multiple patterns, maybe multiple 128 resolution patterns, but that's just getting crazy and unnecessary because we're going to work with a much better and more flexible technique. So in the modular world, when you want to smooth out a waveform like this, what you need is something called a lag processor. And basically that just interpolates between each step to smooth out the waveform you've got. We don't have anything like that in Reason, but we have some building blocks that we can use to create something very similar. So that's what we're going to do right now, pretty much from scratch. So the first thing we need to do is create a Thor in order to process the CV signals for us. So we'll create the Thor, and we'll take the matrix curve CV and send it through the first modulation input on Thor. Okay, now let's open up Thor, remove some of the unnecessary elements, and then head down to the mod matrix here and route CV input 1, our matrix source, to audio output 1 at 100. So we've talked about this before. What we're doing here is converting CV signals to audio. And why do we want to do that? Because we want to run this signal through Scream 4. Okay, so now we just need to take that left audio output from Thor and send it through the Scream 4, and then take the auto CV output from Scream 4 and send that to whatever we want for a destination. And in this case, we're still using the filter frequency on the Maelstrom. Okay, now we should be able to hear the effect of that as a lag processor smoothing our matrix waveform. Let's listen. Alright, you can't quite hear it right now, and that's because we need to do a little bit of manual tuning. And basically that's because our LFO waveform we're sending out of Thor is too loud. It's going into Scream 4 at too high a level. So we just need to tweak this master volume until we find the optimal value that gives us the low points and the highest point. Okay, that's getting pretty close. I think that's pretty close. So you can hear the lowest filter frequency right up to the top. Now you could fine-tune that value a little bit just to make sure all the values are taken into account by the lag processor, but I think that's a really good start, minus 31 dB. So now just to summarize what we've done, instead of sending the matrix signal directly out to the filter, we've sent it through Thor, converted it to audio, attenuated the audio slightly, sent that through Scream 4. Basically what we're doing inside the Scream 4 is tricking it in order to smooth our CV signal. We're using the auto CV output, which is a built-in envelope follower in the Scream 4. It's meant to send out a CV based on whatever audio you're sending into it. So if you send in a very loud drum loop, it's going to send out varying CV values based on the volume of the drum loop audio. We're not sending in normal audio. We're sending in a CV signal that's been converted to audio by Thor. When it's outputted back as CV from the auto CV output, it's smoothed because the signal, regardless of whether we want it to be smoothed or not, the signal coming from the auto CV output is just inherently smoothed. So we're using Thor and a Scream 4 as a lag processor, and we can send that to any destination that requires a smoothed waveform. Once you've created a lag processor like this, you'll find that you run into another limitation, and that's that there is no easy way to dial in exactly how much smoothing you want done to your CV waveform. You get a signal out of the Scream 4 that's smoothed, but you have no control over the degree of smoothing. So there is a technique that we can use by bringing the CV back into Thor that will allow us to control the amount of smoothing. So that's what I'm going to show you now. First, we'll disconnect the Scream 4 from the CV destination and send that signal instead back into the Thor device, CV input 2. Okay, so now what we're going to do is create 2 rows in the mod matrix with CV's inputs 1 and 2. And we're going to send them to the same destination, CV output 1. All right, so now we've got CV input 1, which is our raw stepped waveform, and CV input 2, which is coming back from the Scream, and it's our smoothed waveform, and they're both being sent to the same output. So we'll take that output and send that to our destination, which we're going to still use the filter modulation input on Maelstrom. All right, so now they're both being sent to the same output, and we want a way to toggle between which waveform we're going to hear. So we can easily do this by using rotary 1. And we're going to do it in reverse. So this is just like a CV crossfade. And we'll add a little label here. And we should be able to hear the results. And there you have it. So fully turned right, we have the smoothed waveform, and fully left, we have the original stepped waveform. And of course, there's in-between settings that you can use for a semi-smoothed shape. We're going to continue on with the same lag processor patch and add another significant improvement. One thing I really like about the Native Instruments massive sequencer is you can actually select which steps of a sequence get smoothed. They call it glide in their case, and okay, so we could be using that terminology as well. Glide per step. We're using the terminology of smoothing. So basically choosing which steps in a sequence get smoothed and which don't. And we can actually add that functionality to our patch. So the first thing we're going to do is create a new sequence that's going to make the smoothing a little bit more obvious and a little bit more rhythmic. So let's do that now. Right now, I should mention one of the limitations that you're going to have to work around when you're using the lag processor is that you don't want any steps with the value 0. You can use 1 or just anything over 0 because listen to this. When I switch this step to 0, it's actually higher. It'll raise the filter frequency. And that's because Scream 4 doesn't really know what to do with a zero value that's being sent to it from Thor. It's a little bit technical, but just trust me, if you want to have a zero value step in your sequence, just use, 1 or 2 or something very low. All right, so let's finish this off here. Okay, good enough. All right, so we want to be able to choose which steps out of that sequence are going to be smoothed. And how we're going to do that is opening up the matrix programmer here. We're going to set rotary 1 to control rotary 1 on the Thor, which is of course our crossfade CV. So now that we've got that set up, we're going to modulate, use a combinator modulation to modulate rotary 1 coming from our gate CV. So now that means we can draw in velocity values that are going to, well, you can look at it right here. It might make more sense. So you can see we're changing the amount of, well, this is our smoothing amount right here, remember, because it's crossfading between smoothed and not smoothed. So we're able to change that on a per step basis now. So that might not sound good. Let's give it a shot here. So you can see how you can change per step exactly how much smoothing that you want. Let's try a third, let's randomize a sequence here. We'll listen to that first. So that's stepped and then smoothed. And now we'll just draw in some gate values. Okay, so now we have full control over our sequences. We can create smooth sequences. We can switch on a per step basis back to a stepped sequence. So we have full control over our lag processor. It's everything we need. All right, so I'm going to stop here, save this patch, and then we're going to talk about a few more uses for the lag processor. Now that we've got our really fully featured lag processor, I'd like to show you some other potential applications. I've already mentioned that, of course, you can use it to modulate anything, but let's just go ahead and demonstrate some other uses in this same patch for lag processed modulations. So let's flip our rack around here, and instead of modulating filter, let's try shift. And I'm going to turn our filter off. So let's hear what that sounds like. That's just straight. And now we'll run our modulation sequences. Okay, of course that's stepped. Okay, let's try a different sequence here. Once again, you can see our smoothing amount being modulated here by our velocity controls. And then the third sequence we randomized up. Alright, so that's shift. A next obvious one to do would be perhaps index. For a grain table synth, modulating index is one of the most useful things you can do, so let's give that a try. Let's turn the motion all the way down. Of course, I'm sure you're aware that motion automatically is scrolling through the grain table. But if we're modulating index, we're going to want no motion at all, so that we're doing all the motion through the grain table ourselves. So let's try the Tibetan monks. And we'll go back to our first sequence here and hold a chord. Okay, that's what a stepped modulation sounds like. Let's smooth that out. Well, it's definitely more useful to use a lag processor on a natural sound that usually wouldn't be stepped in real life. So that sounds interesting. Let's try another one of the sequences here. That's kind of interesting now that I've slowed it down some. Let's hear that stepped. Okay, I can't help but add a reverb onto that to hear how it sounds. Let's try Big Blue. And to delay, let's go full overkill mode here. Well, it's definitely pretty cool on Tibetan monks. Maybe one more waveform here. Let's try VS waves. So that's waveforms from the Prophet VS synthesizer, as far as I'm aware. So let's try that out. So that's unsmoothed. Honestly, a little bit of a mess. Let's try the first sequence. In this case, I think it sounds better unsmoothed. Well, that's why we've got a modulation control here to let us change that on the fly, depending on what sound and modulation we're using. Okay, so one more suggestion here, and that's why I've added a mixer to this patch, would be pan modulation. So I'm going to take our CV1 and send that to our pan CV in for this channel. And let's have a listen to what that sounds like. I'm going to switch back to the Juno waveform. Okay, so that's unsmoothed. So this is awesome for pan modulation. When it's stepped waveform, I think it sounds terrible. Let's try one of the other sequences here. And there's stepped. So it's a much more organic way of setting up modulations like panning for sure, using the matrix sequencer. Okay, so that's just kind of a preview of some other directions that you might want to take the lag processor in creating custom LFOs and sequences. So I'll stop there. Sometimes you don't want an LFO waveform that's free running. And just to recap, what that means is, say we play our sequence here. For every note that I play, the sequence isn't resetting to the first step, it's just continuing to play. But what if we wanted a sequence that started when we play a note, or a sweep that started when we play a note, so then it's more like an envelope? Well, you can't do that with a matrix because it just keeps running regardless. So we're going to make one final modification to our lag processor, and that's going to be to change the source modulator from a matrix to a Thor step sequencer. So we can use the same Thor that we've already added to process CV signals. And what we're going to do here is change the source from CV1, which was of course our matrix curve, to the first step sequencer curve. And we'll change this as well. Okay, now let's draw in a basic curve here. I'm going to just make it 4 steps for now. So there you can see we've got our sequence set up. Our smoothing still works. But it's still a free running sequence. So you probably already know what we have to add to the mod matrix. We have to add MIDI key gate to step sequencer trigger. So every time a key is pressed, the step sequencer will trigger. So here I press a note, let go of the note. So we can use it like that. Of course, you could use it like a more smoothed LFO waveform, like if I drew in somewhat of a sweep. Something like that. And once we've got that, of course, we can make use of other Thor step sequencer modifications like the pendulum mode. And then if we want true envelope behavior, we can change things to one-shot mode, which will just run through the sequence once and then stop. Well, in that case, we're still in pendulum mode. Let me just switch back to forward. So you can use that as another envelope, essentially, another mod envelope. And of course, we have 2 curves as well. So we could set this up with a second Scream 4 and actually have 2 smoothed envelopes running in this Thor. All right, I'm going to save this patch as the final patch included in this month's Wizardry. I hope you enjoyed the March 2010 issue. I'll see you all next month. Cheers.